My name is Clarissa Hernandez, and I'm part of the Data and Tools Integration Division. This division, the Directorate-Chief is Mr. Rod Eden, and the Division Chief is Mr. Mario Torres, which you should have met both of them during the meet and greet if you joined the Model and Simulations breakout session. So if there are any questions during the brief, just go ahead and raise your hand with the button on the Teams tool. And if you like something that I said, or if you love something that I said, also feel free to use the other buttons. That's fun as well. Let's see. All right, so we'll go ahead and get started. Next slide, please. Oh, just kidding, I'm the one. Okay, so the purpose and agenda for today's brief. Purpose is, of course, to provide you an overview of the Data and Tools Division, but also just to encourage you to continue pursuing your education and hopefully eventually applying to TRAC and joining our workforce and family. So first, I'm going to talk about my journey to TRAC, and then I'll give an overview of the Data and Tools Integration Division, and then I'll go ahead and dive into our data process, which consists of characteristic and performance data, also known as CMP data. Then we'll talk about our CDRA tool, which is the System and Equipment Data Request Aid, which is hot off the press. So that'll be something nice to talk to you all about. And then we'll also be going over data wrangling and also data visualization. Okay, next slide. So my journey to TRAC, I was born and raised in El Paso. Went to Eastwood High School on the east side of El Paso, if there's any people that currently live in El Paso. And then straight from high school, I decided to go ahead and move to Atlanta, Georgia to attend the Georgia Institute of Technology, also known as Georgia Tech. So I received my bachelor's in mechanical engineering in 2012, and then I was somehow crazy enough to do a 5-year bachelor's and master's program. So I also graduated with my master's in mechanical engineering in 2013. Took a little break from that, and then once I started full-time at TRAC, I had the opportunity to go to New Mexico State University, and I obtained my master's in industrial engineering in 2016. So how I connected to TRAC was through the SMART scholarship. Steph talked about this a little bit, or she talked about this in depth actually in the previous session. And so I really think this was such a blessing in my life to get this scholarship, not only education-wise, but also because it did connect me to TRAC. So just a little background about me. My freshman year at Georgia Tech, being an out-of-state student, tuition was pretty expensive, and my parents were really helping me out a lot with school tuition and just living costs, everything overall. And I really didn't want them to have to do that. I really wanted to be independent and be able to support myself. So I just started applying for multiple scholarships, and eventually I found out about the SMART scholarship, and I was blessed enough to get it, and that's how I got connected to TRAC. So while I was in school, I did my 2 summer internships with TRAC in the summer, so that was nice because I was able to come back home and stay with my parents in the summers, and of course they spoiled me, so that was nice. And of course, just getting to know the people at TRAC in those summers was really beneficial. And then so I did my internship starting in 2012, and then once I graduated, I started full-time in 2014. So SMART Scholarship is great. Go ahead and look it up. The website is there. If you have any questions, you can always feel free to reach out to me as well. So once I started full-time at TRAC, my first role was as a Combat 21 modeler and analyst. And so I did that for about 4 to 5 years. And then I transitioned over to the Data and Tools Division, where I'm an analyst now. So go to the next slide. So the Data and Tools Integration Division is where I currently work under. And so the mission of our division is to generate and maintain and process characteristic and performance data for combat models. And so this includes OneSAF and Combat 21 currently. And we also do design and develop tools to help us with this data development and processing. And we're also responsible, of course, for maintaining this data. So the tasks, of course, number one is we are study team members. Even though we are part of the data division, our ultimate role is as a study team member. So we're not only working with analysts in the data division, but we're also talking to other analysts in the study planning team. We talk to Combat 21 integrators, OneSAF integrators. So you're definitely collaborating across divisions, I would say. And you're also responsible for coordinating data development with providers. So our data, we mainly work with our external agencies such as DAC, the Data Analysis Center, sorry. And we also have other external agencies that we coordinate data development with. You can also look into contacting subject matter experts to develop this data as well. We have multiple green suitors in-house, so I know I've worked with them as well during this process. And you also you're responsible for configuration management of this data. And so what that entails is we use Tortoise Subversion for that to control our changes and make sure our changes aren't breaking anything in our data process. Another piece of configuration management is documentation. And so that's a big piece of it. And so we do use a Jira Confluence to document our process. And that's always felt documentation maybe kind of gets pushed to the side sometimes because you're just always on the go and trying to develop tools and scripts. So definitely planning for that is really important. We're responsible for verifying and validating the databases that we create and produce. And we're also responsible for developing model methodologies. So if we get new data from our providers and the model hasn't accounted for it before, we are responsible for getting with the model developers and figuring out the methodology to get that data to work with the models. And I've mentioned our tools and methods that we work on. Documentation, of course, is huge. And then just making sure that we keep those relationships with our external agencies and making sure that we understand what our roles are in support. So a quick view of our division is we have our division chief, which is Mr. Mario Torres. And overall, our goal as a division is to support studies. So that's the big line right there. And to support studies, we do, you would say, we do three individual things. So we develop our data, we do some analysis on it, configuration management of the data and tools. We develop tools, and then also terrain. We're responsible for developing terrain for the combat models. So there's not any questions. I'll go to the next slide. Okay, so this is an overview of our data process. First, there's of course the source of the data. And so in order to figure out what your source of data is going to be, you have to think about what data you need for the project that you're doing. And so our sources for data are usually the Data Analysis Center. They're the ones that provide us our performance data. We also have the ability to generate our own data, do some surrogation to create our data. And also we can grab data from some online researching or researching documentations, Army documents. So those would be our sources of data. So to get that data and to figure out what data we need to request or look for, we have to work with the study leads, the combat integration team, to figure out what data we need. And so CDRA which I mentioned earlier, that's a new tool that we're going to use to allow users to request this data. So once we request the data through CDRA, then we're responsible for finding that data, whether it's through DAC or we have to research the data. That's our job. So once we have the data and we've collected the data that we need, then we need to merge that data or put it into our repository. So currently we use Tortoise, SVN, or Subversion as our repository. And through this, we're able to track any changes to the data. If we get any kind of data updates during a study, it's easy to identify those updates with Subversion, so that's nice. And also Subversion allows us to view any changes to data that we might do ourselves through the processing of it. So to process this data, we use Python. Python is I would say our main programming language that we use. And so through Python, we create scripts to transform this data into a format that is usable by the combat models or that is usable for us to do visualizations through. So part of using Python is that we are able to wrangle the data. And so by wrangling, I mean we are able to clean that data. So when we get the raw data from any kind of source, the data is not going to be clean. It's not going to be in the format and the structure that you need it to be. So with Python, we're able to maybe remove any blank spaces, fill in any nulls, see if there's missing data. So we try to do all that through Python, through some Python scripts. So once we get the data in a format that's usable, then we can create products from it, right? Then we are able to create those databases for those combat models. And so for that, we have some Java tools on hand to help us compile the data into a single database. Currently, right now, we're working on a visualization tool to automate visualizations for us. And then we're also able to test that data out. So usually we work with the Combat 21 team to give us their current and latest scenarios so that we can do some testing with it. Or we also have some expertise in-house with Combat 21 integration, so we can also create a quick scenario to do some data testing. So I'll go to the next slide. Okay, so for characteristics and performance data, the slide shows the different functional areas that we do get data for. So direct fire, indirect fire, artillery, and our models are high resolution. So everything from the round, the missiles, I mean, we get data for everything. Defensive aid suites, infantry. So this is just a quick slide on the different types of characteristic and performance data that we receive in-house and then process for our combat models. All right, so next we're going to talk about CDRA. So the first part of our process is to request the data, right? Figure out the data that we need. And CDRA is a great tool to do that. So this tool was developed in-house by one of my team members, Mr. Uriel Amaya. He is the developer of CDRA. He did this in Java. And what it does, if you can look at the top left picture, oh gosh, sorry, phone call, is through this, the first tab is the information tab. So the user of CDRA here has the ability to insert information about the study. So what's the study name? What's the purpose? When do they need the data by? Who's the study lead? Who's the integration lead? The data lead? Anything that pertains to the study we capture through CDRA. And then the user can also give us information about the scenario. What's the scenario? What's the time frame? What's the friendly time frame? What's the threat time frame? So this CDRA just captures all the information that we need as data analysts to submit our data request. So on the right-hand picture, shows what the equipment tab looks like. So you're able to see different platforms, which would be your different systems, whether it be air or ground systems, and then you can see any weapons that are associated with those systems and all the munitions. So the user is able to quickly see what data they can request, and if there is something on here that they really need for a study but they don't see, then they can propose that data or make a proposal for data, and that can also be done through Seadra. So similar to this equipment tab, we also have it for sensors so that you're able to see all the sensors for a platform. You're able to see radars or emitters, defensive aid suites, and mines. So through Seadra, of course, like I said, you can select and deselect your data that you want, and you're able to see descriptions, whether it be for a sensor, a system, a munition, whatever you like. You can search in Seadra. So if you're searching for specific system or specific munition, you can do some searching, and you can also do some filtering. So if you only wanted to see the friendly items or the friendly systems, or if you wanted to see your threat items, you can do that as well. So next. So once we request our data using Seadra and receive that data, the raw data, our next goal is to wrangle that data. So our main goal is to process that data that's in a readable format for our combat models, so which is Combat 21 and OneSAF. And so what we decided is that we would process this data into CSV files. Why CSV? Well, it's human readable and it's compatible with most applications. So that's always a plus. So once we get this raw data, it doesn't just end there though. We are still responsible for transforming that data, maybe generating additional CSV files to support the M&S dependencies. So ultimately, I would say we have around 2 CSV files for a single study. And of course, going through that manually is just not doable. So automation is key. And how do we automate our quality assurance, quality control? Well, that's through Python. And so the process that we go through is shown on the top right. So first, of course, we extract our data. We make sure that it's structured correctly. Then we want to clean it. And then we want to merge it into any existing data that exists. And once you do that merging, then you can do your grouping of the data. So if you need to combine different elements together to get a better picture of what that data represents, you can do that. And then you're able to, of course, validate that data, make sure it looks good, and then we publish it and create a database for our models. So why Python? Well, Python is the fastest growing language to date. It's versatile, it's easy to use, and it's fast to develop. And I can attest to that because I was not a Python programmer when I joined the data division, but it's something that I had MATLAB programming experience, and of course I had some programming with Combat 21, so it was really easy for me to pick up Python, and I think it was just a great decision for us to use Python as our programming language. And so there are libraries that make it easy to use Python but you also have the ability to create your own libraries. So I'm going to talk about DataViz next, and for DataViz, we actually are creating, you would say, our own library, our own package for that tool. So next is data visualization. So I would say one of the maybe last steps once we process the data and have it structured correctly, it's clean, then we want to look at that data. And so what's the best way to look at the data or to get a story from the data? And that could be through visualizations. But these visualizations have to be stimulating. You can't just plot these and call it a day. It really is an art and a science to figure out which visualizations go best with the data. So an example is on the right. On the top, we have we have the raw data for munition impact points. And so you can just tell there's a blob of impact points, but there's different colors, and I don't know what they mean. Some colors are overlapping others, and I'm not sure. I'm just not getting a good story out of this. But once you transform that data, then you can maybe improve on your visualizations. So now we're able to break out the visualization by range, by shooter speed, by target speed. So the more that you break it out, then the story gets a little bit better. You can see that as you're closer, maybe your impact points are tighter, and as your range increases, your impact points disperse more. So data visualization is an art, and we are developing a tool to try to automate these visualizations for our characteristic and performance data. And we're building the tool right now with Python and SQLite, but just from the past few, I would say, weeks from developing the tool, we've just learned a lot in terms of what visualizations are going to work, which ones aren't. And I think this is just a tool that's going to be constantly evolving just due to the volume of the data that we have. And as we start to share it with other analysts outside of the data division, we're also getting different ideas on how to approach this. So it's an exciting area that we're working on, but definitely it's going to be a tool that's going to be in development, I think, for a while. So my closing remarks is, if you're pursuing an education, just stay focused and just always be on the hunt for internships and scholarships. I think that's probably the way that I stayed afloat to make it through, but it's a lot of work, but the money's out there. The scholarships are out there. You just really need to apply, and you'll get them. So the TRAC data process, as I discussed, includes defining the data that you need, collecting that data, and then wrangling the data to get it into the format that you need to create a product, and then being able to analyze that data, which we're doing and working on with visualizations. And to end, data analytics is a very fast-growing field, so that we hope that you'll consider joining the TRAC family to solve these complex problems that present themselves, and also ultimately to support the American soldier. So with that, that's the conclusion of my brief, and I'll take any questions.
Can you talk a bit about major and how that impacted your ability to just work in this environment?
I'm sorry, you broke up a little bit. Can you repeat your question?
Yeah, hopefully it'll work now. Can you talk about your major and how it relates to this field?
Right. So my major is mechanical engineering, and my master's was in stress analysis. So definitely different than what I'm doing at TRAC, but what I've learned is that with, I think, any engineering degree that you get, whether it's mechanical, and it's aerospace, and not even necessarily even engineering, I would say any STEM, is that at the end of the day, what your degree means is that you can think, you can problem solve. No matter which kind of job you end up going with, that's what that paper means, is that, hey, this person really knows how to problem solve and think. And so that's what I've applied at TRAC, is my problem solving skills. And so while I'm not necessarily doing mechanical engineering design work, I'm applying what I learned in school, which was overall to problem solve. So I would say that's the biggest contribution of my degree.
Thanks.
I have a question.
Okay, go ahead.
You guys mentioned a lot Python, and I haven't really used Python, though I do have a little bit of experience with MATLAB and also Tableau. in Tableau, we're also working with creating dashboards and collecting databases, data to clean them up and create visuals. How hard would it be to apply that Tableau visualization to the Python program?
Right. So Tableau, we don't use within our division. I don't know if other divisions use that tool, but I think with that you have experience with visualizations, so that's always a plus. And again, like I said, if you were able to figure out how to do that in Tableau, and if you have MATLAB experience, I don't see you struggling to apply that to a different programming language. So I think what's always key is just having that foundation there, because honestly, I thought the same when I looked at Python. I was like, oh my gosh, I'm not gonna be able to do this. But once you start applying what you learn, applying what you know from your foundation, then you just start learning really quickly and just growing. So I think you would be fine.
Thank you.
Yeah, no problem. Are there any other questions?
All right, well, thank you, Clarissa. If there's no more questions, we can take a break until about 3 o'clock, and then we'll come back for Combat 21 behavior modeling.
Okay, thank you.